Sensor fusion is combining of sensory data or data derived from disparate sources such that the resulting information has less uncertainty than would be possible when these sources were used individually. The term uncertainty reduction in this case can mean more accurate, more complete, or more dependable, or refer to the result of an emerging view, such as stereoscopic vision. The data sources for a fusion process are not specified to originate from identical senses. One can distinguish direct fusion, indirect fusion, and fusion of the outputs of the former two. Direct fusion is the fusion of sensor data from a set of heterogeneous or homogeneous senses, soft senses, and history values of sensor data, while indirect fusion uses information sources like a priori knowledge about the environment and human input. Sensor fusion is also known as data fusion and is a subset of information fusion. Sensory fusion is simply defined as the unification of visual excitations from corresponding retinal images into a single visual perception, a single visual image. Single vision is the hallmark of retinal correspondence. Double vision is the hallmark of retinal disparity. Examples of sensors: radar, sonar and other acoustic, infrared, thermal imaging camera, TV cameras, sonobuoys, seismic sensors, magnetic sensors, electronic support measures, phased array, MEMS, accelerometers, global positioning system, sensor fusion algorithms. Sensor fusion is a term that covers a number of methods and algorithms, including central limit theorem, Kalman filter, Bayesian networks, Dempster-Shafer. Example: sensor fusion calculations. Two example sensor fusion calculations are illustrated below. Let and denote two sensor measurements with noise variances and, respectively. One way of obtaining a combined measurement is to apply the central limit theorem, which is also employed within the Fraser-Potter fixed interval smoother, namely, where is the variance of the combined estimate. It can be seen that the fused result is simply a linear combination of the two measurements weighted by their respective noise variances. Another method to fuse two measurements is to use the optimal Kalman filter. Suppose that the data is generated by a first-order system and let denote the solution of the filter's Riccati equation. By applying Kramer's rule within the gain calculation, it can be found that the filter gain is given by inspection. When the first measurement is noise-free, the filter ignores the second measurement, and vice versa. That is, the combined estimate is weighted by the quality of the measurements. Centralized versus decentralized. In sensor fusion, centralized versus decentralized refers to where the fusion of the data occurs. In centralized fusion, the clients simply forward all of the data to a central location, and some entity at the central location is responsible for correlating and fusing the data. In decentralized, the clients take full responsibility for fusing the data. In this case, every sensor or platform can be viewed as an intelligent asset having some degree of autonomy in decision-making. Multiple combinations of centralized and decentralized systems exist. Levels. There are several categories or levels of sensor fusion that are commonly used. Level 0 data alignment. Level 1 entity assessment. Tracking and object detection, recognition, identification. Level 2 situation assessment. Level 3 impact assessment. Level 4 process refinement. Level 5 user refinement. Applications. One application of sensor fusion is GPS, INS, where global positioning system and inertial navigation system data is fused using various different methods, e.g., the extended Kalman filter. This is useful, for example, in determining the attitude of an aircraft using locust sensors. Another example is using the data fusion approach to determine the traffic state using roadside collected acoustic, image and sensor data. A practical example how to combine data of different displacement and position sensors in order to obtain high bandwidth at high resolution can be found in this master thesis. one can see the applied methods of optimal filtering or the Kalman filter.